Hey people. So last class we talked about how graphically you can show exactly what's happening in a double displacement reaction. You know, if it's soluble, what does that mean? Well, soluble means when you drop your chemicals in water, they will separate into their ions. Okay, that's when you can no longer see the crystal, because when things are separated into their ions, they form a solution, and you shouldn't be able to see the ions. Obviously, that's pretty crazy if you think about it. But however, when two ions are insoluble in water when come together, we call that a precipitate. They will come together, and you will be able to see the solid formation that you're supposed to see. And we also looked at how to write up a net ionic equation, and hopefully you guys did all the questions that you were asked to do and check your answers. Now today we're going to look at concentrations. Okay, so make sure you concentrate. You get it? Nah, whatever. All right, so there are many types of concentration units, and they all pretty much explain really the same thing, but looking at different phases, I guess. And we're going to look at three popular ones today. Okay, they're popular in the sense of being more realistic in everyday life. Okay, so people understand these things. Just normal people who doesn't study, who's really not into chemistry, they would see this. They will see this in the supermarket. They will see it in some sort of chemicals that they use in their bathroom and kitchen. These are all concentration units. Okay, and the first one is called percent VV. Okay, V stands for volume, and volume is based on milliliters. Okay, now can it be liters? Yeah, it can be liters. Just make sure they're consistently liter. Now, I'll show you exactly what I meant by consistently liter. Okay? Now, when will you see a concentration unit that uses percent VV? Well, usually when you're mixing a liquid into water. Okay? If you're mixing some sort of chemical liquid with water. Like, for example, vinegar. Yeah, there you go, vinegar right here. Okay, when you buy vinegar from the supermarket by the jug, it says something like 5%. Now, what does this 5% mean? Well, this 5% means 5% VV. To give you a better rundown, you're looking at 5 milliliter of this stuff called acetic acid dissolved in 100 milliliter of water, because 5 over 100 is 5%, right? So let me say that again. When you see 5% vinegar, that means they took 5 milliliter of acetic acid and dissolved it in 100 milliliter of water. That's what it means. Okay? 5% VV. So let's fill in the blank here. Okay? The concentration of solution are sometimes expressed as percentages, especially on labels of products like vinegar. Okay? For example, a vinegar label 5% VV acetic acid means that there are 5 milliliter of pure acetic acid. Acetic acid is a weak acid. Don't let the word fool you. Just because I said weak doesn't mean that it doesn't have the ability to hurt you. When this acetic acid is in its pure form, that means it's highly concentrated. All that stuff can hurt you, and hurt you bad. Okay? Obviously, vinegar is not going to hurt you. Why? Because it's so diluted. It's dissolved in a lot of water to make that a vinegar. Something that you can put in your sweet and sour sauce. Something that you can put in your French fries. Yeah, I just say French fries. I am one of those weirdos that put vinegar in my fries. Yeah, and don't ask me why I do that. I put vinegar in a lot of things. I like it in my dumplings. I like it, as I said, in my fries. I sometimes like it in my soup too, depending on the type of soup. So I'm a fan of vinegar. Yeah, you guys are all probably grossed out now. Anyway, let's continue. Dissolved in every 100 milliliter of vinegar. Oh, dissolved in what? I think what they really meant to say here is dissolved in 100 milliliter of water. Okay? So the VV notation indicates the two liquids because acetic acid is a liquid, water is a liquid, and when they're mixed together, that's why you have VV, volume over volume. And as I said, the two volume has to be consistent. So either they're both milliliter or they're both liters. You can't have one being milli and the other one being base. It won't make sense. At least not here. So the first V refers to the volume of the solutes, which is the acetic acid, dissolved in the solution of the second V, which is the solution. Or you can say water. It doesn't matter. Okay? All right. Where C is the concentration of the solution. Okay? So V solute is the volume of the solute, whereas V solution is the volume of the solution itself. Okay? I guess I really shouldn't erase this. I shouldn't really erase that, because I think I know what it's supposed to mean. To liquid. Okay, I think I know what they meant. They meant by 100 milliliter of vinegar water. So the 100 milliliter is the full thing. Okay, so if you're trying to make a 5% vinegar, what you're doing is you're taking 5 milliliter of acetic acid dissolved in 95 milliliter of water. That's what it meant. Okay? So yeah, let's not erase that vinegar. So vinegar, water. You'll see once we start doing the math. All right. No, the unit used to measure the volume must be the same. They must be consistent, like I said, either both ml or they're both L. Okay. So here's a problem. We're going to be doing some of these questions here. Okay, based of course on this formula right there. So a photographic stop bath contains 160 milliliter of pure acetic acid in 600 milliliter of solution. Now, be careful of the wording here. 600 milliliter of solution, meaning that this 160 milliliters of pure acetic acid is already in here. They didn't say 600 milliliters of water. They said 600 milliliter of solution. As I said, that means in here already has 160 milliliter of pure acetic acid. What is percent VV? All right, it's pretty simple. Can't get simple than this. So the percent VV here is equal to the volume of solute, which is the 160 milliliter of pure acetic acid, divided by 600 milliliter of the solution times 100%. As simple as that. Okay, nothing, I guess, too tricky. The only thing tricky about this is this number right here. Okay, you have to see if this number is a solution or is it just water. Because if this was 600 milliliters of water, then you're gonna have to add these two numbers for the denominator. But no, it says solution. Okay. All right, hopefully you guys have a calculator handy, and this is going to be 27%. Okay, now, some people like to put 27% VV. I'm one of them. Okay, just to indicate the fact that you're looking at liquid dissolving in another liquid. Okay. All right. How about this one? Oh. I guess I have another question for you later on, but yeah, I have lots of questions for you to do for homework, so let me just go through the second concentration unit. So the second concentration unit is very much similar to the first one, but instead, this is percent WV. Okay, the W stands for weight. When do you use weight? You use weight usually for solids. So most likely, when you see percent WV in your household product, you're looking at stuff that was pre-dissolved. Okay, it was a solid, but it was dissolved in water at a certain amount, specific amount. All right? Like I've mentioned right here. Now, what are some products that are like that? Well, I can think of stuff like saline solution. Anybody know what saline solutions are? They're kind of like a salt solution where people they inject it up their nose. So some people they have a they have a cold and their nose is extremely stuffy and they have trouble breathing and stuff like that. And you can go to a drugstore and you can buy these saline solution. Okay, and you would just squeeze those saline solution up your nose to kind of clear up all the mucus and stuff like that. Okay, and these saline solutions are made by dissolving solid salt in a specific weight in a solution of water. Okay, another example is dyes. Those things that turn your hair to a different color or turn your clothes to a different color, dyes, tie-dye dyes. Okay, yeah, I can see that there's dyes, a solution of dyes are WV as well. All right, so let's fill in the blanks. So when the solute is a solid, the percent concentration is followed by WV. The weight is usually given in grams. Okay, a solute is, I think they meant by mass. Okay, and people use weight and mass pretty interchangeably, but they're not really talking about the same thing. Mass is about the matter within. Weight has something to do with the gravitational force, measured in grams. Okay, and the volume of the solution is measured in milliliters. So you're looking at mass of solute over volume of solution. You can even think about the volume of solution being the volume of water, because you might not want to convert this mass into a volume by multiplying it by density. It's just really not something that you want to get into. All right, so a lot of people just look at this volume as volume of water. Okay, unlike this example right here. All right, so just something to keep in mind, where C solution is the concentration of the solution. Okay, where M solute is the mass of the solute. Okay, and the V solution is the volume of the solution. As I said, you can even abbreviate that as the volume of water, because it doesn't matter in milliliter. So your answer will be in grams per milliliter. Man, doesn't that sound familiar? Doesn't that sound familiar? I wonder why I wrote a D there. But of course, you have to multiply by 100 because you're looking at this as a percentage. So let's do an example right here. I have 3 examples that I want to do with you. So the first one. A salt solution is formed by mixing 2.8 grams of sodium chloride in enough water to make exactly 250 milliliter of solution. So I guess for some people that like to draw this out, here's a it looks like a shoe actually. Here's a graduated cylinder. Okay, so you put 2.8 grams of sodium chloride in there. Then you put some water in there to make sure that at the end it is 250 milliliter. I want to know, what is the concentration in WV? Well, just like what the formula says, okay, WV is the mass of the solute. This will be 2.80 gram divided by the amount indicated, which is a solution. That's 250 milliliter. Okay, times 100. Now, what would that be? Well, you guys can do this in your head. You can if you want to. But one of the things that you should be very careful of is making sure the units are correct, eh? Making sure that the numerator is in grams and the denominator is milliliter, or else you're going to run into problems. All right, the answer is very simple. It's really just 1.12%. I hope I'm right. Okay, because there are times that I'm not. All right, let's do example 2. The mass of pure hydrogen peroxide. Ooh, okay. You are looking for the mass now, huh? Would be dissolved in 150 milliliter of 6% WVH2O2 solution. So you have this hydrogen peroxide, okay? The stuff that you use to kill, I guess, germs whenever you get a cut, so therefore you don't get an infection. So you're looking for mass. So C equals to M over V times 100. In this case, you are given C to be 6% is equal to mass over 150 milliliter. What is mass? That's pretty easy. It's M over 150 is equal to 0.06. So M is equal to 0.06 times 150, and that will give you mass in grams, because that's what WV is measured for. Okay, so the answer, of course, is 9 grams. All right, that's just a rearrangement of variables, not something that is challenging at all. Number 3, a box of apple juice, I love apple juice, contain a solution of fructose in water. The reason why I'm laughing is that, do you think they really use fructose? Calculate the mass of fructose that would be present in 175 milliliters of a 12% solution. So again, this is really the same question as the one above. Oh, what did I do here? Okay, this is really the same question as the one above. Okay, so let's move right into M over 175 milliliter is equal to 0.12. I sort of already converted the percent into a decimal, so I'm not writing the same thing. So M, okay, is really equal to 175 times 0.12 is 21 grams. Okay? Simple, isn't it? It really doesn't get harder than this at all. As I said, lots of those questions for you to do tonight, and just get you to practice to be good at this. All right. Lastly, you have a third type of concentration unit called parts per million. People call it ppm. Okay, and if you see ppb, that means parts per billion. And if you see ppt, that's actually parts per trillion. Okay, Or maybe sometimes people call it parts per thousand, but they're not really the same thing. We all know that. But parts per million is the most popular, I guess. And when do we use ppm? When would you see ppm? Well, not household products for sure. Okay, let me give you an example when you'll use ppm. Let's say the amount of chlorine in a swimming pool. You will use ppm. Okay, the amount of mercury in the river. Yeah, I guess you'll use ppm. So you can see that ppm is used for very, very, very small concentration. Now, why can't I use percent VV or percent WV? Why can't I use that? It's because if you use that, your number is going to be 0.0000 something. And that bothers people. Imagine, hey, the amount of chlorine in the swimming pool is 0.000022%. You'll be like, huh? That's a lot of zeros to take care of. So is that big or small? We all know it's small. We all know that it's small. Because it is small, let's not use percent. Let's have another unit for it called ppm. Now, what you need to know with ppm is this. This is the key. ppm is nothing more than milligram of solute over liters of solution. In this case, liters of water. Okay? We know milligram is a very small entity. Thousands of a gram. So you're looking at very, very, very little amount. A liter is pretty big if you think about it. Okay, it's half of those 2-liter pop bottles that you guys chug down your system every now and then whenever there's a party. Okay, so let's do some of these questions. Let's do ppm. Okay. Right there. I have, again, a couple of problems that I want to work through with you. So ppm is very similar to percent WV because you're still looking at the mass of solute. But of course, instead of grams, you're looking at a milligram. V is the volume of solution. So instead of looking at milliliter, you're looking at liter. The concentration, well, C is the concentration of the solution measured in milligrams per liter, or simply just say ppm. All right. So let's take a look at problem number 1. In a chemical analysis, 2.2 milligram of oxygen was measured in 250 milliliters of pond water. What is the concentration of oxygen in parts per million? Okay. And by the way, there's a device out there that can measure these kind of things, dissolve oxygen. That's actually one of the projects that we did last year when we went to the pond outside. You know that pond outside Milliken Mills High School? Yeah, we actually took some water in there and measured the amount of oxygen in those water to see how much it can, how it can sustain life. I mean, we were thinking of putting turtles and goldfish in there, and will they survive? I don't know. We don't want to try because nobody wants to take care of turtles and goldfish, because if we were to drop those life in there, somebody's going to have to take care of them, and nobody wants to volunteer to take care of no turtles. All right, let's do this. So ppm is equal to milligrams per liter. Ooh, we have a problem. Mass, we don't. That's in milligram. That's chill. That's cool. The problem is right here. Okay? This is in milliliters. ppm is said to be measured in liters. So you're going to have to convert this. Hey, let's do some factor label method just for fun, okay? I know you can do this within an instant, but let's do factor label method. Okay, factor label method says you multiply, okay, by a fraction that gives you the relation. So when the relation crosses out, you get your unit of desire. So this is going to be 0.25 liters. Okay, so you divide by 0.25 liters. So what is this? 2.2 divided by 0.25, that will be 8.8 ppm. All right, nice and easy. The next question, also nice and easy. There's also unit conversion involved because I love unit conversion. ppm is equal to, okay, look at the solute here. The solute here is in grams. So you're going to have to somehow change this to milligram. Okay, so the amount of lead here is 5.0 times 10 to the power of negative 5 grams. So you're going to change that to milligram. Pretty simple, because we know that 1 gram is equivalent to 1,000 milligrams. So grams cancel. Okay, so what you're going to have to do is find out exactly what 5 to the power of negative 5, times 1,000. You're really just moving the decimal 3 places to the left. So this is just 0.05 milligram. Okay? So 0.05 milligram divided by, do I have to do anything with liters? No, it is in liters. Okay. Oh, that's easy. So the answer here is C is equal to 0.05 ppm. This is how much lead is in your drinking water. The question is that a deadly number? No, that's not a deadly number. In fact, if you were to analyze lead in your drinking water in some older school that still have their pipes made out of lead, you may even find it to be around this number. And you don't see people dying from lead poisoning, do you? Okay. But we stopped using lead to make our pipes. We use a certain type of plastic. Okay? Anyway, hopefully you guys are comfortable with the 3 types of concentration units. You guys are comfortable with ppm, which is used to measure very, very small concentration. You guys are happy with percent WV, which is used to measure solutes in a form of solids in concentration, and you guys are happy with percent VV, which is measuring the volume of a liquid in solution. Okay? To get good at this, I need you to do this. So page 177, I want you to do question 1 to 11, okay? They are based on percent VV, percent WV, and ppm. Next class, we will talk about a concentration unit that you guys are most likely be responsible for a whole lot in this chemistry course or in future chemistry course, and that is called molarity. We will look at this concentration unit because pretty much, I would say 80% of the time, in a lab, in those stock bottles or in those prepare bottles of chemicals, they're usually given in molarity concentration units. And molarity is based on, like you guessed it, moles of solute over liters of solution. Anyway, I will let you do this page now, and we'll talk about this tomorrow. Bye, guys.